Algebra 1, number 5.1b, we're going to talk about dividing using exponents. So we now know that we can multiply like bases using exponents by adding the exponents. We can divide like bases using exponents by subtracting the exponents. Multiplication is the opposite inverse of division, and we add exponents for multiplying, so it makes sense to subtract for the division one, because addition and subtraction are inverses. So if we've got 2 to the 5th power over 2 to the 2nd power, we would just subtract 5, take away 2. We get 2 to the 3rd power. But the base number cannot be a 0, and we must have the same bases. They must be like bases, okay? So here is the formal quotient rule for exponents when you divide exponents with like bases for any non-zero. So it can't be a 0, rational number a, and for all whole numbers, m and n, we would get a to the m power over a to the n power, and it would equal a to the m minus n. We would subtract. So take a look at this one. We've got 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. So that's 3 to the 5th power over 3 to the 3rd power, isn't it? We would subtract 5, take away 3, so we'd have 3 to the 2nd power when it's simplified. But basically, this is what we're doing. We're getting rid of this one, and this one, and we're eliminating them. And now we just have 3 to the 2nd power over 1. So that'd be 9 over 1, wouldn't it? It would just be 3 times 3, 9. See? Now look at this one. We've got x to the 6th power over x to the 2nd power. We just subtract and get x to the 4th. We can cancel and get 4x's over 1, x to the 4th power, right? Because anything over 1 is itself, right? Look at this one. Now we've got two variables. A to the 7th power times b to the 5th power over a to the 3rd power times b to the 2nd power. Just like this is the tens place and that's the ones place, we keep them separate. 7 take away 3 would be a to the 4th power, and 5 take away 3 would be b to the 3rd power when it's simplified, see? And check out this one. This one's really different. We've got p to the 5th, q to the 4th, over p to the 2nd, q to the 7th. When we do the 5 take away 2, we get p to the 3rd power. But when we have q to the 4th power and we want to take away q to the 7th, that's really big. So that's going to push us into the negatives, and it's going to be negative 3. And it's okay. We can have exponents that are negative 3. We're going to talk about that in the very next video, 5.1c. So you're going to want to see that one, all right? Because this is what's happening. All right, I just want you to remember that the base can't be 0. You can't have 1 over 0 to the 3rd power, okay? Cross that off. So we've got 5 to the 0 power, and that's going to equal a 1. Because if we have 2 to the 3rd power over 2 to the 3rd power, it's got the same numerator and denominator, doesn't it? So if it's got the same numerator and denominator, it equals 1, doesn't it? But what if we did 3 take away 3? Wouldn't we have 2 to the 0 power? Yeah, we would. So it'd equal 1. Okay? So if you got 5 to the 0 power, that's going to equal 1. We're going to discuss this in 5.1d. Okay? We're going to talk about the zero exponent rule some more. And we can see it. The exponents are going 1, 2, 3 going up, and they're going negative 1, negative 2, negative 3 going down. Well, we know that if we write a number over 1, it means that number. So we're going to go from 1 to 5 over 1, which is 5, and then 5 to the 2nd power is 5 times 5 over 1, and 5 to the 3rd is 5 times 5 times 5 over 1. That's 125. And as we go into the negatives, we're becoming a fraction. Negative 1 becomes 1/5. Negative 2nd power becomes 1 over 5 times 5, see? And we remove the negative from this by turning it into a fraction. It's now a positive number. So when you see a negative exponent like this, just think fraction. Just put a line and a bar over the top of it as a fraction and take away that negative sign, okay? 3 to the negative 4th power is 1 over 3 to the 4th power. It's a positive, see? So remember, when the exponent is on the inside of the parentheses, it is affecting only the variable it is next to. And even if it's not in parentheses, it's only affecting the variable it's next to, okay? It's when the exponent is on the outside of the parentheses, it gets distributed to each one. So this would then become 2 to the 3rd power, x to the 3rd power, because it's distributed to both of them, see? All right, we're going to talk about negative exponents in the very next video. And don't forget that there's going to be video description. In this video's description, there's going to be links to the previous videos, similar ones or helpful ones, okay? And we're going to talk about the negative exponent rule in the very next video. And after that, we're going to talk about the zero exponent rule, okay? So you'll be a exponent whiz when we get done, okay? You'll be super exponent, okay? I'll see you there. Bye.